This is lesson 1.5 on grouping. So we just got finished learning about our quadratic formula. So we saw where it came from. We generally won't need to know how to derive the formula. We'll just need to know how to use it. Now the quadratic formula is kind of it gives us the last instance of an easy polynomial to solve. So when we have a quadratic polynomial, our quadratic formula is going to be able to give us the solution to an equation, finding where that polynomial equals 0, without too much difficulty. Now you might disagree. Sometimes those square roots get to be a little intimidating, but it's a routine. We'll always do the exact same process when finding the solution to a quadratic equation. For polynomials with degree higher than 2, so degree 3 we call cubics, degree 4 we call quartic, quintic, and so forth, those in general are much more difficult to find the solutions to. There are set techniques to find, for example, the solution to a cubic polynomial and to find solutions to a quartic polynomial. That's actually an interesting point in math history. During the Italian Renaissance, there was actually a little bit of a controversy there. There's a bit of a rapscallion, Cardano, who allegedly took credit from a colleague in a published paper, but that's besides the point. We are not going to look at those techniques. They're a lot more difficult than just using our quadratic equation. So in general, cubic, quartic, higher degree polynomials, they're not nearly as easy to solve as our quadratic polynomials. Now, one simple technique, which is what we're going to focus on today for solving some of these polynomials, is what we call grouping. If we group together similar terms, factor out certain terms within the polynomial, we can get identical binomials or trinomials, identical sets to show up. We can factor out those similar terms and in that way make our polynomial a little bit more manageable, a little bit easier to digest. All right, so consider this example. X cubed plus 3x squared minus 4x minus 12 equals 0. So we see that this is a cubic polynomial, cubic equation that we're working with. The highest power of our variable is 3. So we cannot use our quadratic equation. We can only use quadratic equations our quadratic formula with quadratic equations, where the biggest value of our exponent is 2. So here the only simple technique that we have to use is grouping. Again, grouping is not the only technique. In fact, grouping is not guaranteed to work. This won't necessarily provide us with a solution, but whenever we encounter an equation like this with a polynomial degree bigger than 2, I recommend at least trying this. The amount of time that you will save if it works is worth risking the time, just taking a glance real quick to see if it works. Okay, so the way that grouping works is when we take our equation, we're going to, surprise, surprise, group certain terms together. Now, generally, we're going to pair them up. In any of the examples that we run into, that's actually going to be the trick. We need to pair up our terms. So we're going to pair up our cubic and squared terms and our first degree and constant terms. Within each term, take out the highest power of x that you can and the biggest common factor that you can. So in this case, we're going to take out an x squared term from this first bit. So when I take out an x squared from x cubed plus 3x squared, my x cubed term becomes x. My plus 3x squared term becomes plus 3. Similarly, with my negative 4x minus 12 term, I'll take out the biggest value that I can. Now, pay attention to these negative signs. There's kind of a give and take here. In some cases, you're going to want to factor out the negative. Sometimes you'll want to leave it in. 99 times out of 100, though, you're actually going to want to factor out a negative if you can. So here, notice that I can factor out a 4 from both 4 and 12, but there is no variable term that I can factor out. So since this is negative 4, that will be what I factor out. So negative 4 is what I will factor out. So my negative 4x becomes positive x. My minus 12 becomes plus 3. So notice now I have two terms, x squared times x plus 3 and 4 times x plus 3. They both have an x plus 3 term in them, so I can factor that out. Just like here, how I factored out an x squared, I can factor out this binomial from these two terms here. So I factor out the x plus 3. From my x squared times x plus 3 term, that leaves just the x squared. And from my negative 4 times x plus 3 term, that leaves just my negative 4. You're going to be left with, in general, quadratic terms and linear terms. If it's a linear, rather, you're basically done. If you have a quadratic, see if you can factor it. In this case, notice we have the difference of two squares, so sure enough, we can factor x squared minus 4. We're going to factor it into x plus 2 and x minus 2. So just like before with factoring, the only way that this whole equation can equal 0 is if one of these individual terms equals 0. So for this whole thing to equal 0, either x plus 3 equals 0, x plus 2 equals 0, or x minus 2 equals 0. So that tells us that our solutions are x equals negative 3, x equals negative 2, x equals positive 2. So we can write our final answer as x equals negative 3, or I'm fine with you writing this as plus or minus 2. All right, let's consider a little bit more difficult example. Now, the only examples that we'll see on our drill quizzes will be cubic equations, so the ones just like the previous example. The only time we would encounter something like this would be on an application quiz or an application portion. So we would not have to do this within the 1 minute time frame. So we have this new equation, x to the 5th minus 2x to the 4th plus x cubed minus x squared plus 2x minus 1 equals 0. Okay. Now, just like before, we are going to group things together. Now, let's approach this blindly. Let's suppose that we were not too sure if this would work. So let's go through. I'm going to go ahead and tell you that this is not going to work. So let's maybe use a different color for this then. So this is going to be our bad approach. So what if we tried to pair things up like we did previously? So what if we tried to pair up our x to the 5th and x to the 4th term, x cubed, x squared term, and our constant terms? So if we try this, if we look at x to the 5th, 2x to the 4th, it looks like the biggest term I can pull out of that is x to the 4th. So that will leave me, that's positive, sorry, it's a stray mark there. X to the 4th, when I take that out, that will leave me with x minus 2. All right, the biggest term I can take out of here is x cubed minus x cubed minus x squared. I can take out an x squared. So I take out an x squared. That will leave me with x minus 1. And then my last term looks like I really can't take anything nice out, so I'll just leave it as 2x minus 1. So we take a look at what we have here, and things are not nearly as nice as before. What we want to see is for these remaining terms, so x minus 2, x minus 1, 2x minus 1, in order for grouping to work correctly, these need to be exactly the same thing. So unfortunately, this approach is not going to work. However, we're not completely out of luck. Let's try grouping in a different way. Rather than pairing things up, let's take them 3 at a time. So let's take these 3 terms together and these 3 terms together. So let's take x to the 5th minus 2x to the 4th plus x cubed together, and then x squared plus 2x minus 1 together. In our first set of 3, it appears the biggest term I can take out in common is an x cubed. So if I take out an x cubed, that's going to leave me with x squared minus 2x plus 1. My second set of terms, there's not too much it looks like I can do. But since my first term is negative, let's go ahead and factor out a negative 1 from all of that. So this will become positive x squared minus 2x plus 1. Lo and behold, notice now that we do have two common terms here, so we can factor that out. So when I factor out my x squared minus 2x plus 1 term, that's going to leave behind an x cubed from this portion and a negative 1 term from this portion. Negative, there's an implied 1 there. Okay, just like before, these two things, the only way that this whole equation can equal 0 is if one of these two things individually equals 0. So we must have either x squared minus 2x plus 1 equals 0, or x cubed minus 1 equals 0. This equation, notice that we have a factorable quadratic. We can factor this as x minus 1 times x minus 1. So this portion gives us solution x equals 1. This portion, we have a cubic. We haven't encountered these yet. So I'm going to cheat for you a little bit. When we have just a cubic all by itself, we can actually take the cube root of both sides. So I take the cube root of both sides. Here we're able to do this because we're only worried about our real solutions. If our instructions told us to worry about complex solutions, there's a little more work we have to do here. But the instructions will explicitly state find complex solutions if we need to do that. Cube root of x cubed is x. Cube root of 1 is 1. Remember, with odd roots, we do not have to worry about that plus or minus that we do for square roots and other even roots. So even though this is a complicated equation, it turns out to be pretty boring. The only real solution is just 1.